Hello everyone, welcome back to my channel. My name is Devaparna Datta. I am a scientist of the Department of Atomic Energy, the Government of India, and I'm also an UPSC aspirant. And on this channel, I share my UPSC journey and share a little bit of knowledge that I've gained in the past few years. So today we are going to talk about a topic of science and technology, and that is quantum computing. Now, quantum computing is something that has been in the news all the time, right? We always see something or the other about quantum computing, either about its applications or some quantum chip that has been developed. So it's repeatedly in the newspapers, and it has also been asked. Questions have also been asked by UPSC in its prelims, right? So the thing with UPSC and science and technology topics is what it does is when the first time it will ask you about a particular technology it will ask you a very simple question like where have you heard about qubits? It will start with that, and eventually it will ask you a few eventually in the next few years it will talk about some of the applications. It will see whether you understand or you can predict the applications of a particular technology, and finally one fine year it might ask you about its basic principles. Like it will give you a bouncer and it will ask you about its basic principles to understand whether you understand the basic working of this particular technology. So now that quantum computing has been in the prelims questions for past few years, so we should now be expecting a question about its basic principles, and so it's high time that we stay prepared with it. And so today we will be talking about quantum computing, and we will talk only as much as is required for this examination. So we have to remember that we don't have to become quantum physicists, okay? So we have to remember that we are preparing for an exam that will test only our general understanding of this technology. Now, so before recording this video, I was talking to a quantum physicist. He is also a colleague. So I was asking him a few questions to get a better understanding of quantum physics and quantum computing. And during this conversation, I had this confused face in some stages of this conversation. And the best thing that he told me is that if you're confused, that means you're getting it. Okay, so this is something you have to understand and accept about quantum computing. That is, it works on the laws of quantum mechanics and quantum physics, and these laws have not yet been fully understood by even the greatest minds or the scientists of the world. So please, when you feel a little overwhelmed or confused with certain topics, please remember that there are certain things in quantum computing that we just have to accept, even if our mind does not agree to it, like because we have not witnessed something like that. So with that thought in mind, with that idea in mind, let's get into understanding whatever we must and whatever we should understand about quantum computing, and whatever little will be expected of us, okay? So I tell this to my students whoever comes to our lab or the trainees, that whenever you want to understand a technology, you have to first understand what it does for us, right? What it does for the mankind, because only then you will find interest in knowing how it works. So that is exactly how this video will go. We will first understand what quantum computers are and what do they do, and then we will understand how it works, the laws of quantum computing, okay? So to start, we have to first remember that quantum computers are not advanced forms or superior forms of our normal computers, okay? Please do not mistake them as a more advanced or superior or a more expensive form of our normal computers. Computers and quantum computers, they work on completely different technologies and laws. And so if I have to explain you better, then if normal computers are candles, then quantum computers are bulbs. So you can put a lot of candles together, maybe the light will be brighter, but that does not mean you will be able to make a bulb. This is because these two work on completely different technologies, and this is something that we must remember, okay? So, and if you have to talk about, and definitely this is a more superior technology because it works on the laws and the systems of quantum physics. So if you have to understand how much superior this is, I can give you the example of Google Sycamore. So it is Google's quantum computer, and it can solve mathematical problems which will take a normal computer to solve. It will take around 10,000 years. It can solve it in 200 seconds. So that is the level of supremacy or the level of efficiency that we are talking about in this technology. So this is not what we are going to talk about. And when we put a lot of candles together, we make a supercomputer, okay? Like when we put a lot of processing units together, we make a supercomputer. But supercomputer is not what we are going to talk about in this video, and please do not confuse supercomputers with anything related to quantum computers. It is a completely different technology. Okay, so having said that, having understood that, now let us understand what a quantum computer can do. So imagine yourself in a gaming parlor. We have all been to these gaming parlors, right? Where there's a computer and we put in some coins and then we play a game and we get some rewards. So imagine yourself in a gaming parlor and your opponent is the computer, and it's a normal computer. It's not a quantum computer. So your opponent is a computer, and let me explain this game to you so that we can understand how to play it. Okay. So yes, so in this particular game, the game starts with a coin, which is it is at the head state. Okay, imagine this as a coin and it is at the head state. So what happens in this game is, first the computer plays, and the computer can either choose to flip the coin or not flip the coin, but you will not get to know whether the computer flipped the coin or did not. So the computer will not reveal to you whether it flipped the coin or not. Next, you go, and you also can choose to either flip the coin or not flip the coin, but even you do not have to reveal it to your opponent, which is the computer, that whether you flipped it or not. Again, in the next round, the computer will again flip the coin or not flip the coin, whatever it chooses to, and it will again not reveal. And finally, the coin will be revealed, and if it is heads, then the computer wins, and if it is tails, then you win. So now I know this is a little it's a stupid game, but if you had to predict that what will be your chances of winning in this game, what would you predict? It's a 50-50 chance, right? If there is no cheating and if there is no intervention, then there is a 50-50 chance that you win the game. And this game was actually played 1,000 times, and it was seen that with a normal computer, and it was seen that the chances of winning is 50% for anybody. But suppose I swap this computer with a quantum computer, then what do you predict the chances of your winning is? It should still be 50-50, right? But no, it's not 50-50. When you play this with a quantum computer, the chances of the computer winning will be 97%. And it was observed after playing this game with the quantum computer for 1,000 times in IBM. So now you will think, oh, that's complete cheating then. Like, how can the computer win 97% of time? It's a 50-50 probability. But no, even that 3% that the quantum computer lost, it was because of technical errors in the computer and not because it was going to lose. This is because, now let us understand why this thing happens. So this thing happens because our normal computers, they work with binary bits. So they understand your input as 0 or 1, okay? And but the supercomputers, they work with something called qubits. Now qubits are quantum systems which are always in a state of superposition. Now what is superposition? So superposition is a state where all the possible outcomes can exist at the same time. They can exist together in the same time till the system is stopped or observed. Okay, so let me explain you easily. That is, suppose you have a coin. Okay, when it's in your hand, you have either heads or tails, right? When you flip it and you catch it, again you either have heads or tail. But what is the state when it's in the air? When I'm flipping it, this time when it's in the air, so it is moving like this, right? So what is the state? It's both heads and tails, right? It's both heads and tails at the same time when it's moving in the air. This is a position of superposition. That is, both heads and tails are possible. This is the state that qubits stay in, that qubits exist in. So when it's almost like, as I said, it's almost like water and oil being stirred together. Okay, they are being stirred together, and the quantum computer is able to separate them the moment you observe it and give you one state. Okay, so that is why it was able to win 97% of time, because every time that you were flipping and the computer was flipping, the computer's answer was in a superposition. It was in superposition. It was neither heads nor tails. And so when the game ended, it got the favorable outcome. It could get the favorable outcome because it had neither placed heads nor placed tails. It was in a fluid spectrum. A fluid spectrum would be something like which has both the states, maybe 70% of heads and 30% of tails, or 60% of tails, 40% of heads. So it was a fluid state. It has all the possible outcomes, and it is like in a spectrum. Okay, it's like in a wave. So we will understand it better when we understand superposition, which is the basic law. So once we have understood that this is something quantum computers can do, they can exist in the state of superposition, then what are the possibilities with this computer? So they are immense, right? The possibilities are immense. They can open up so many applications, like suppose designing private keys for encrypting chats which can be sent from one place to another. Now this private key will also be in a state of uncertainty, right? It will be in a state of superposition. So for a hacker to copy your key secretly, it will not be able to he or she will not be able to copy it exactly the same way, because it is difficult to factor in the uncertainties. The hacker has to literally break the laws of quantum physics or quantum mechanics to hack into your system. Further, suppose you're designing, it can also revolutionize healthcare, right? Suppose you want to design drugs. So in the drugs, we design these molecules, and these molecules have so many atoms and so many combinations of atoms, right? And they are always, and for their analysis and their designs requires so much, like so many calculations, and they have to club all these features together in one calculation. And this can take a toll on normal computers, but not supercomputers. Supercomputers can efficiently do this because quantum computers can efficiently do this because they are working on the same principles on which these molecules and atoms are working. So whenever you think about the applications of supercomputer, please do not limit yourself. Can you imagine, like anything in which you require high computation speeds, in anything which you require simulations, in anything which you require efficiency of calculation, huge data sets are there, and you have to arrive to a conclusion. In anything, in encryption, in AI, in anything that you can imagine that requires dealing with huge amounts of data, quantum computers can be of immense help. So whenever UPSC asks you a question about applications, please keep your mind open. Please do not restrict yourself. If you have not heard about a particular application, don't think that, no, I did not hear about it, so maybe quantum computer cannot help in it. Please do not do that. Until unless it's something very bizarre, until unless it's something that you can outrightly eliminate, please keep your mind open. For example, if UPSC says, can it be used in disaster management? Yes, it can be. Can it be used in precision agriculture? Yes. Can it be used in satellite image processing? Yes. Can it be used to design drugs? Can it be used in precision medicine? Yes, 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 it can be. It has huge applications, and we only understand around 10 to 20% of the laws of quantum physics now. So imagine what happens when we are completely able to master this technology, and what kind of huge applications will it open for us. So please, this is one thing that I want you to take back, that please keep your mind open. Now let's understand the laws of quantum physics, because as I said, that since UPSC has already been asking about the chips, and it has been asking about its applications, and also talked about qubits, now it might go a little bit into the laws on which it is based. So there are two laws that we need to study. One is of superposition and the other is of entanglement. Now before going into this, I want you to remember that please, if you get a little confused while I'm explaining this, it's completely okay. As I said, if you're getting confused, then you're understanding, then you're already getting it. And please keep your mind a little open, because these are some things that we do not witness in our reality around us, and so it might get a little overwhelming sometimes, and we might find ourselves thinking that how is it even possible. But please try to accept certain things even if we have not yet witnessed those. Okay, so first let's talk about superposition. Now, what is superposition? So as I said, superposition is the state in which all the outcomes can exist together in the same state. They are existing, like when I'm flipping the coin, this is the superposition state, when it is both heads and both tails. And don't just restrict yourself to a coin, to two outcomes. Imagine a dice. There are 6 outcomes, right? When the dice is in your hand, it can be 1, 2, 3, 4, 5, 6. When you roll it and it stops, it can be 1, 2, 3, 4, 5, 6. But what about when it's rolling? It can be anything between 1, 2, 3, 4, 5, 6. So that rolling of the dice, that position of that is the rolling of the coin and the rolling of the dice, that is the position of superposition. That is the superposition. And quantum physicists found out that quantum systems are always in the system of superposition. They are always existing in a system, in a state where all the outcomes are possible, and the outcome only comes when we observe it. So imagine all the outcomes are in one system in the form of a wave. The moment you observe this wave, the wave collapses and you get one outcome. So I know it sounds weird, that how is that possible, what observation actually means, and this was the exact question that came to the minds of the scientists when they discovered this, that what does observation actually mean in an experiment then? And does the observer have to be conscious that he is observing this thing? And does that mean that we as observing entities, as observing individuals, do we keep changing our reality? So it not only challenged the laws of physics, the laws of physics that we knew, but it also challenged cultural aspects of it, right? It challenged what reality means to us. So that is why we have to keep our mind open when we are understanding technology like that. So when scientists like Einstein and another scientist, Schrödinger, when they were discussing this state, so they both found it spooky, they both found it unrealistic, but they also wanted to explain it to everybody, right? It's very difficult to explain this to people. So Schrödinger, he was a scientist, and he came up with this thought experiment to explain superposition better. Now, I will explain you the thought experiment, but I have tweaked it a little because I'm a cat lover and I don't want a cat dead in a box. So I have slightly tweaked it, but I'm sure you'll get the gist. So now let us imagine this thought experiment, okay? Let us imagine that I have this bag. I have a bag, okay. Now, let's imagine that this is a soundproof bag, okay? So it's a soundproof bag. No sound of from inside the bag can come to me. And inside this bag, I put a sleepy cat. So suppose this is a sleepy cat. He's half sleepy or he's completely sleepy. So I have this cat and he's sleepy. And also in this bag, I put a radioactive atom. And it is in a state of, it is anywhere between decay, in an intact state or in a state of decay. So when it decays, right, it can decay, right? At any point it can decay. I do not know when it will decay. I do not know. But I know that at any point it can decay. And once it decays, the radioactive atom decays, it can trigger an alarm. Okay, so it can trigger an alarm. So what do we have in this bag? We have a bag which is soundproof. We have an alarm clock which can be triggered by the decay of a radioactive atom, but we do not know when the atom will decay. And we have a cat, a cute little cat, okay? And the cat is very sleepy. So when I put all of them in that bag and I close the bag, okay, at no point now after the bag is closed do I know that whether the atom has decayed or not. If I don't know whether, I don't know, right? I don't know whether the atom decayed or not, and so hence I don't know whether the alarm was triggered or not, and whether the cat is awake or asleep. So if the alarm triggers, then the cat will wake up, right? But at no point when the bag is closed, when the bag or the box is closed, do I know that whether the radioactive atom underwent decay, whether the alarm got triggered, and whether the cat is awake or asleep. So at this point, when the bag is closed, at this point the cat is both awake and both asleep, right? So this is the state of superposition, that both the results can exist at the same point. And only when I open this bag will I know whether the cat is sleeping inside it or whether the cat is awake and irritated because of the sound of the alarm, okay? So this is what Schrödinger used to help people understand, people like us, understand what superposition really means. Okay, and that is all you need to know about superposition. That is, it is a state where both yes and no, both 1, 2, 3, 4, 5, 6, and all the states can exist at the same point. And only when we stop and observe it, only when we observe it, will the wave collapse. The wave of all the possibilities will collapse and one outcome will come. Okay. So this is the first law that we need to understand. Now let us understand what entanglement is. Okay. So to understand entanglement, I will use 2 coins. Okay. So suppose these are 2 coins and they are not entangled. Okay. So there are 2 coins, they are not entangled. So if I toss this coin, it has a 50-50 possibility of being a head or a tail. And again, if I toss this coin, it also has a 50-50 possibility of being a head or a tail, right? Now, the outcome of this coin will not affect the outcome of this coin because they are not entangled. Now, suppose I can do some magic. I do some magic and I entangle them. And I entangle them in such a way that if this coin, after I flip it, it has a 50-50 possibility of being head or tail. But if it's head, then this will automatically be tail if I can entangle them in such a way, and this entanglement will exist irrespective of the distance. So suppose I give this coin to astronaut A, an astronaut whose name is suppose astronaut A, and I place him on a space ship and I send him to Mars. And then this coin I give to astronaut B and I place him or her in a spaceship and I send her to another planet which is many light years away from Mars, and I tell both of them that only after 10 years of travel will you flip the coin, and once you flip the coin, the moment you both have to, because they'll flip the coin at the same time, because I've told them a particular time after which they have to flip the coin, right? So once they have both flipped the coin, I'll ask them that the moment you get the result, you communicate them through radio. You communicate the result to each other through radio signals. Now this radio signal will take several years to travel to astronaut A. Astronaut A's radio signal will take several years to travel to astronaut B, and astronaut B's will take several years to travel to astronaut A. But the moment astronaut A has tossed the coin and got head, he or she automatically knows that the result, or the result of astronaut B is if it's tail, then it's head. So this, I know this sounds spooky, and how you must be thinking that how are these two coins or these two particles communicating with each other? How do they know? How does this one know that if I am heads, then that one has to be tails? So if this, how does this know that, okay, that one is head, so I have to be tail? So this is why Einstein called it spooky action at a distance, because Einstein believed that nothing can travel faster than light. So how is this communication happening? How are they communicating with each other? So this is what entanglement is. And I also want you to remember that no matter what is shown in sci-fi movies, it is not that information is traveling faster than light here, okay? Because if that was so, then we could predict, right? We could predict from beforehand, but it is not possible. It is only when I will toss this, it's only when I toss this coin will always have a 50-50 probability of being heads and tail. And only when it's heads and I've measured it, only then will I know that this one is the opposite one, okay? So I know this sounds overwhelming. I know you must be thinking that how are these particles communicating with each other, and if it's true for particles, why is it not true for coins? It's not true for coins, right? So yes, it is a bit spooky, but this is what the law of entanglement is. That is, when two atoms or two particles, they are entangled with each other, then the state of one, the fate of one will determine the fate of the other. So if I toss this, even if there's a 50-50 chance, if I get, there's a 50-50 chance when I toss this, but once I toss this and I get head, there's a 100% chance that this is a tails, okay? So this is the law of entanglement, guys. And I know it's a little spooky, and that's why Einstein called it spooky, but these are the two laws on which the quantum computing works, and I think we should remember both of these, because question is likely. And other than that, we always have to keep a track of what is there in the news. Like normally from the news, if they'll ask you the same type of questions, that like if there's a chip, which company built it, or something, like they'll ask you very basic questions that has been there in the news. And the other questions they can ask is regarding terminologies, that is, what is entanglement, what is superposition. They can give you options. They can, like qubits, they have already asked. So these are the only possible questions that can come. So what I have now done is, I will now show you the question that has been already asked. Actually, I don't need to show you. It's the qubits question, right? You already know. And the Majorana 1 question also, they asked you this year. So I have tried to make 3 questions from ChatGPT, with the help of ChatGPT. I've given it the right prompts, don't worry. It's not some random question. So let's try to solve them. And I'm sure it will boost your confidence. And just pause the video and try to solve it yourself, and then see the answer, okay? So yes, guys, these are 4 questions that I have made, which I think might be helpful. And these are I expect that the questions in UPSC also should be around like this kind only, and unless it's something from the current affairs. So please, I will not give you the answers. Please try to solve them. Pause the video, try to solve them, and post your answers. If you have solved them, post your answers in the comment section. And I hope they will be helpful. And I'm not giving you the answers because I want you to find these answers. That will help you understand the topic better. So this is the second question. I hope you can just pause it and watch it. And this is the third question. This is a question that I think you should solve properly, because this is on the laws that quantum computing works on. And then this is the fourth question. That is it, guys. That is it from me today, and all the best. I hope I was of help. And please, if you're solving these questions, please leave the answers in the comment section so that I know. Thank you.